Today is a good day because behind me I've got 3 Picoscope boxes and 2 of them were sent over to us from Picoscope themselves. One of them had this WPS500 pressure transducer inside it, and in this video we're going to take a look at what you get with this sensor plus 4 really cool tests that you can do with it. Okay, so what we've got here is the pressure sensor kit itself. We've got the diesel glow plug adapter kit, which we're going to take a look at in a minute. So if we open up this box, we're straight away presented with an array of different kind of adapters and things like that. Now, this pressure transducer, they designed it in a way that you could use it with other test equipment as well. So let's say you already had a specific brand of diesel compression tester, you can actually fit them onto this. So what they've done is supplied a different range of adapters that fit a different range of kind of standard workshop tools. So we've got like different fuel testing adapters here. There are then some converters as well for testing different types of fittings, and then we've got these different fittings for the different types of spark plugs for going inside cylinders. So this one here is what you would use most if you were going to be doing compression testing, and what you would do is just screw on the adapter that you needed there. It's quite straightforward. In the back of the case we've got a really nice long BNC connector. This is normal BNC, not BNC plus. We've got a USB charging cable because this is battery powered. That's quite good, so you don't have to have a power supply connected. Just remember to keep it charged. We've got a leak off pipe, so we're going to be using that today. We've got this hose here, which it's a rigid hose, so it can fit inside exhausts for doing exhaust pulse testing. And we'll also be using one of these today, and this one has that tyre type Schrader valve on the end, which you commonly find on fuel injection systems. So we'll be taking a look at that today as well. We've also got like this generic hose, which is just a rubber type hose, which I suppose you could fit to anything that you can get onto the end of it there. So I've connected it up now, and you can see that the pressure transducer is just outputting a very low voltage. If I you can see that it's outputting a very low voltage based on the pressure that's coming in there. Now this does have 3 ranges. It's got 500 psi, which is around 34 bar. We've got 50 psi, which is around 3.5 bar, and then a really low one for around 5 psi or 345 millibar. All of the custom probes are in there, set up, ready to go. So if we go down here to WPS500X, we can see there that we've got those 3 ranges there. Look, 34.5 bar, 3.5 bar, or 350 millibar. You can then go up to the channel settings to change the range. So you can see here we can go right up to 35 bar depending on how much pressure you want to measure. There are also 3 zoom settings, so I'm going to demonstrate them to you now on the tyre. So what I'm going to do is set it to range 2. So if we just hit range 2 there, and then make sure that we change the probe to match whatever you've got the sensor set to. Click range 2 there, 3.5 bar. Now by selecting the right range, you're going to get the most detail for the pressure that you're measuring. So I'm not sure you're ever going to really use this to measure tyre pressures. I did put a post on the Mechanic Mindset Facebook page recently as a bit of a joke. But this is a good way to demonstrate the zoom feature. So we've connected that up here. If we check on the screen now, we can see that that's gone over range. So let's just put that into the correct pressure range on there. We'll go 1.5 to 3.5 bar. So now when we connect this up, we can see that we've got our measured pressure there. So about 1.6 bar. The tyre pressure is a bit low, but this car's been sat in here for a while. What I'm going to show you now is this zoom feature. You can see on the oscilloscope display that as I'm trying to push my thumb into that tyre wall, there's not much change on the waveform. So what we can do is use the zoom feature. What the zoom feature does is it gets rid of all that positive pressure that's underneath that waveform. So if we press it now, we can see that it drops down and is around about 0 on the scale. So now look, when we press it, we can start to see a bit of a change. If we press it again to zoom 2, it's a bit more pronounced. And to go another level, we can bring the range down to 690 millibar, which we couldn't see before because it went off the screen. And now when we press that tyre in, look, we can see those small fluctuations in the tyre pressure. And of course, it's not going to be much. So the zoom feature lets us basically see the very small changes that you would see on that top kind of pressure waveform without ignoring all of that positive pressure that's underneath it. So another way to quickly demonstrate the feature, if we go to the lowest range, 350 millibar, and do the same on here, we can see when I blow into the end of the transducer there, there's not much change. However, if we go to zoom 1, we can see a bit more change. Zoom 2, and then zoom 3. We get to see more and more detail. So those features might be good for doing like pulse sensor diagnostics and things like that. Okay, so let's move on to the first of our 4 tests, and that's in-cylinder pressure testing. We're going to give it a go on this petrol first and then have a look what it can do on the diesel engines. So if we just remove this spark plug, and then we can attach the appropriate kind of thread for this type of spark plug. And don't worry if it gets kind of stuck in there, it's like an open-ended hexagon on there and they're quite easy to get out. And we'll just screw that in there. And we connect the pressure transducer just on the top like that there. So for petrol engine measurements, because of the pressure that it can measure up to, 35 bar, 500 psi, we can do the test either cranking or running, whereas on a diesel you mustn't allow it to run, otherwise it will just blow a hole in the pipe. So we'll connect up now and go to range 1 as we've set that pressure transducer up, and we'll make sure that we're measuring the right amount of range. I've put it up to 35 bar. It's also worth mentioning that for Picoscope automotive users, there is the guided test feature here. And if you go in there to pressure transducers, we've got there, look, WPS500X Pressure Transducer. And we've got a load of preset measurements in here. So let's give one a go. We've got in-cylinder pressure. Let's do idle. And what we get is the guide and the settings file. So the guide will give us some information about this test and what we might expect to see. And it puts a waveform up on the screen for us as well. It's also changed the settings. If you want to download the waveforms from today's video, then make sure you head over to mechanicmindset.com and sign up for the free access area. There you'll be able to see all of the saved Picoscope waveform files from all of our YouTube videos. And if you want to take your oscilloscope diagnostics to the next level, then make sure you check out our Automotive Oscilloscope Masters training course. Okay, so we've got an image there of what this should look like. What I'm going to do is see if we can take a reference waveform of this image, just make it red, and then we can compare that to the waveform that we get on this vehicle. So if I hit start, we're ready to go. Don't forget that that red one there is our reference waveform. Let's just bring it down out of the way and we'll have a look at that in a moment. So we'd gone off the screen a bit there with the range that it had set up, so we can just increase that quite easily there. And now we can see that the waveform is fitting on the screen there. And if we just pause it and bring that up, we can see there that we're similar, okay? So although the waveform is very similar, it's not the same. Now that doesn't mean that there's a problem with this car. The reference waveform we've got here in red will have been taken from a different vehicle. Now you can go to the waveform library to find if someone's uploaded the waveform for this car, and what you'll be able to do then is use the rotational rulers to actually identify the timing. So what we can do is identify one full cycle and zoom into this. And from this, you'll be able to look at the different points of interest on the waveform. So we've got compression coming up here. The top of that waveform would be top dead center. It then comes down for the expansion stroke or combustion if you had a spark plug in there. And then we get the exhaust. So as this pressure starts rising there, that shows us that we've got an exhaust event taking place as the cylinder starts to come back up to top dead center again over here. Okay, so this is basically exhaust back pressure. And then the pressure drops again where the cylinder's dropping for that intake stroke. And then back to bottom dead center and compression. So looking at these points of interest, you can very quickly work out if you've got a timing problem. You can also check things like exhaust back pressure. Let's just tap that into 0 there. And you can see there that our exhaust back pressure is low and around 0. And you can also analyze this part of the waveform looking for leaks. So you might do this test following a compression test to identify why a cylinder might be low on compression. There are other things that you can do with it as well. So you can look at the pressure on a much longer time base and rev up the engine to see what happens to the overall cylinder pressure. And you can even connect up the ignition coil and check where the ignition is taking place. Just make sure you fit a tool that puts the spark plug on the coil, otherwise you could end up burning the coil out running it without the plug. Okay, so now let's do a compression test on the diesel engine. First, I'm going to quickly show you the diesel glow plug adapter kit. And it basically comes with a full suite of all the different glow plug adapters that you might need. It also comes with this page with all the separate ones on there. And as far as I understand, you can buy these separately. So the one that we want here is for the Volkswagen engine. Just down here, and I found it there. And then inside here we've got the glow plug adapter for the car we're going to be working on. So the test on the diesel is going to require us to remove one of the glow plugs. So I'm going to go for this one here, as it's quite easy to get to. Hopefully it's not seized in, as they are common for doing that and snapping off by the time you kind of finally work it free. Hopefully we'll be all right. Okay, so the connector's off there. They're just a 10mm socket. It's come out quite nicely there. And then what we should hopefully see is that the adapter we've got there matches the glow plug we've got. So we can see that the threads line up just there, and the end of it lines up as well. So this is the right one for the job. Okay, so I've just been and found the adapter for the glow plug there. So we've got the same pipe that we used for the in-cylinder pressure, and we've got this brass adapter here for going onto the end of the glow plug. So it's a bit tight down there. Hopefully I'll be able to get it off okay. I'm sure there won't be a problem. Let's connect that up to there. Okay, we're in. Very important, very, very important. Make sure you disable the engine from starting, or there's a good chance you'll blow this hose apart and probably damage your transducer. So you can do that by either disconnecting the fuel rail pressure control valve. That just ensures that all pressure in the rail is now dumped into the return, or you could disconnect all of the injectors. Either one of those will do fine. But I would avoid just disconnecting like the fuel pump fuse or something, because some diesels will actually pull the fuel from the tank to operate. So pulling the fuse in the tank doesn't make a difference. Okay, then we just need to turn our transducer on and connect that up like that. We are ready to go. Okay, so I've just increased the time a bit for this one so that we can crank it over and then come back and see what we caught. What we'll notice is that this waveform doesn't really show us the same amount of detail as the petrol waveform did. Now, a lot of that is down to the fact that diesels run on maximum air, so the throttle valve is always open. In fact, it should be like that on this car. However, once we put a fault in the system, it switches to a conventional kind of engine. So if you just bring this down to 0 bar, it helps put it into perspective. And then what we'll also do is just put the phase rulers up so we can see where the 4-stroke cycle lays on this waveform. Okay, just align those up with our compression peaks. We can see here that we've got the obviously the compression where the pressure rises up to around 21 bar. Okay, so quite a bit more pressure than the petrol engine we had. And then this is our expansion stroke, which would be our combustion. And here we can actually see a very small exhaust valve event there. Okay, so there is a bit of a change there. However, the exhaust stroke and the intake stroke are pretty much flat, whereas on the petrol engine we had lots of detail. Now that's not a bad thing because it means that we can identify problems very easily. So if you had a valve timing issue, that would show up with either a sudden spike or a sudden drop in pressure. Again, make sure that you get a known good to reference so that you don't end up condemning mechanical problems that aren't actually there. Remember, all engines are quite different. In fact, I do know that these Volkswagen engines do have a system that have a variable valve adjustment on them, and it adjusts the inlet and exhaust valves at the same time. So I suppose a problem with that could end up showing on an in-cylinder pressure test. So we've done a compression test on the engines with the WPS500, and the next test is going to help you find out where a compression loss might have gone, and that's to use it for pulse diagnostics. So we've got this kind of standard pipe that we can use to put into the intake, or we can use it on the crankcase through the dipstick tube, or we can use it in the expansion tank. We've also got this kind of rigid pipe here, and that will allow us to put the WPS500 in the exhaust and leave it there like that. That's a really nice accessory, that is. So what we're going to do is just use this flexible hose here and connect it onto this kind of turbo actuator pipe, just like that. The other great benefit about using the WPS500 pressure transducer for this test is that it's not susceptible to vibrations like a normal pulse sensor. The other thing with a pulse sensor is that because it works with a piezo crystal, there is a reaction for every action. So if you increase the pressure, the signal goes back down again, even though the pressure is still held high. With the WPS500, you're going to read whatever pressure reading you get without the reactions that you would get on a pulse sensor. Okay, so because this is going to be quite a low pressure, I'm going to put it on range 3 and we'll see what we get. So we'll just check the probe is on range 3, and I think it is. It was maximum 350 millibar there. We could see that on this scale here. However, we're going to want the lowest pressure we can, so let's change it to the 69 millibar scale, and we'll crank it over and see what we get. I've disabled the engine, so I've removed the fuel pressure control valve so we can crank the engine over without it starting. Okay, it didn't look like much happened there. However, let's just scroll back through, and there actually we can see that we've got some activity there. And although it's not much, let's just zoom in. What we're looking for is really not much activity. We don't want any kind of regular breakouts that might indicate a leaking intake valve or something like that. So that's pretty good. We can also add some filtering on there, and we can see even more detail for this waveform. So I'm going to save this waveform, and then what we're going to do is use the zoom feature to see if we can get any more detail out of this measurement. Okay, so I've just turned the low pass filter off again. Let's just add the zoom. So if we go to zoom 1, 2, 3, that's the most aggressive zoom that we've got. And we can see here that we got a bit more information this time, okay? what we can see is where we've got the initial cranking and then these small pressure drops where the intake strokes are happening inside the engine. So if you were doing this test on a petrol engine, you could use the ignition to actually trigger to those pressure drops. So you could work out which one was for which cylinder and identify the location of any problems. However, it's a little bit more difficult on the diesel because we've had to disable the injectors from actuating. For that particular test, it's also good practice to isolate the crankcase breather, just in case you've got anything coming through the crankcase that could show up as a possible fault. For the third test we're going to take a look at, we're going to connect up to the fuel rail on this petrol engine here. It's a port injection system, so low pressure. Remember, the WPS500 won't go high enough for any of the high pressure fuel systems. That goes for common rail diesel and GDI gasoline and petrol engines. So let's connect this up and have a look at what we can see. So we're just going to be connecting onto this Schrader valve here, which is part of the fuel rail. Okay, there it is. It's just made connection. Tiny bit of fuel has come out because it holds a bit of pressure in there when we're switched off. Okay, so we'll just connect up the WPS500 here. I'm also going to connect up the leak-off bottle. I've got a small bottle already on the end of this, and hopefully it should be big enough for bleeding the air out. That's all we want to do. Okay, so the engine's running. We've got the WPS set on range 1 because the pressure that we want to read is just over the mark. It's nearly 3.8 bar there. So of course we wouldn't be able to measure that with range 2. It only goes up to 3.5 bar. We've also got amp clamp on injector number 4 here. We're just clamped around this wire just here. And at the minute, we can't really see much detail on this line. It looks like a kind of a flat pressure line there. So first of all, if we just try kind of zooming in to that area, not much to see there. What we'll try doing is using that zoom feature. So let's put it onto zoom 1. Okay, now we've got some data here that kind of correlates with the injection system here. We can see that this injector here opens and we get like a drop in pressure. In fact, let's just go down another zoom there. Let's go to zoom 2. Okay, those drops are now a little bit easier to see. So if I just stop it here, you can see that with this injector, we get that drop in pressure here. We get 1, 2, 3, 4, then we're back to that injector that we're measuring, okay? What I'll do is I'll save this one here as our known good, and then we'll disconnect an injector to see if we can see anything on here. Now, you might want to do this for checking the mechanical operation of injectors. I know we can use the voltage and the current to check that. However, it doesn't prove that the injector's not blocked and actually allowing any fuel to flow through. So for engines where it's quite difficult to access the injector to physically check if it's spraying fuel, this is like a nice way to be able to do it. Okay, so I'm going to make a reference waveform here. We'll just make that one green. So now there's our reference waveform. And what I'm going to do now is disconnect injector number 1. So let's just stop it there. So that there looks like it's worked really well. Let's just move this injector number 4 up a bit and just remind ourselves of the known good. So this is a 4-cylinder engine with the firing order 1342. So this would be 4, this would be 2, 1, 3. Okay, so now if we look at this compared to our faulty waveform, we can see that on cylinder 1, where the pressure dropped before, it didn't, it stayed flat. So we can see there that we've got an issue mechanically with that injector. And of course we have, because we disconnected it. So what we could also do is use the phase rulers again, just to separate that up into 4 so you can see it a bit easier. So here, after every line, we can see on the good waveform the pressure drops. So we get the line here, the pressure drops. We get the line, the pressure drops. Here, the pressure drops, and again it drops. Here on the bad one, we get the drop, we get the drop. Here we don't get a drop, and then we get a drop again there. So clearly see that this has picked up that mechanical injector problem. Okay, so the fourth test I've got to show you today is a really cool one, and it's for diagnosing diesel injectors. Now, the way diesel injectors work, we get a high pressure coming in. The needle is actually mechanical in operation. There's no electrical operation that moves the needle. What happens is the return in the injector is opened, which creates a pressure difference, and then the needle moves up, okay? So the injector needs a return to operate. Every time that injector operates and activates, a very tiny amount of fuel comes out that return. So this test is really pretty cool. Okay, so the setup that we've got here then, we've got the amp clamp on injector 1 just so we can see where that's been activated. Here are all the injector returns on the top here. And what we've done is we've gone into that return for all 4 injectors. So that would usually go back into this pipe here, and on this car it's back to the tank for that one. I've clamped off this bit here, and we've got this other bit of diesel leak off pipe that I've kind of put onto the end of there and stretched that over the input to that WPS500. We've then got the leak off return going down into a bottle here. It shouldn't leak off much if there's no faults. So be careful if you suspect a faulty injector, make sure you've got a bigger container. And that purge valve on the WPS500, I've actually forced it open with a cable tie. So when the injectors operate, any fuel is going to come through here and straight out. We're going to be using range 3 because that's the most sensitive. I suppose you could use the zoom if needed, but range 3 should be fine. So let's take a look at what we get. Okay, so you may have to run the engine for a little bit just to fill up that return line again. I can see we've got fuel dripping out there, so we better get a move on. Now what we've got, look, is this injector activates and we've got this small rise in pressure afterwards. And we can see there are 4 of those for 4 injectors. So what I'm going to do is make a reference waveform again. And we'll disconnect an injector. Okay, so I disconnected injector number 3 there, and what we can see here is this is injector number 1. If we take the known good pattern, look, we've got the hump for 1, 3, 4, 2. And the blue one here, channel A, is the bad system, and we can actually just overlay that there and see straight away that we are missing that hump for cylinder 3. So that is a really cool test, and really helps for diesel injector diagnostics, which can sometimes be quite difficult. So make sure you head over to mechanicmindset.com to the free access area where you can download these waveforms. And big thanks to Picoscope for sending over the equipment. Let us know what you think about today's tests in the comments below.